All right, so we have this equation here. So we are thinking of we were in the we were thinking of z as a function of x and y, and so we don't have an explicit formula for z, but we have an equation satisfied by x, y, and z. So again, z is a function of x and y. And so I'm going to do this in a different way, which is going to use, so let me first copy this equation. Oops. Okay, so let me copy that here. Okay, so this is the equation that we have. And again, I want to find the partial of z with respect to x. So the first step that I'm going to do is I'm going to rewrite this equation as x cubed plus y cubed plus z cubed plus 6yz minus 1 is equal to 0. So the first step is basically that I'm writing the equation in a way so that the right hand side is 0, right? So I'm rewriting the equation so that the right hand side is 0. Now whatever I have on the left now, I'm going to call that the capital F of x, y, and z. So now on the left hand side I have a function of 3 variables. So there is a special theorem called the implicit function theorem that says the following. The implication of that theorem is the following: that the partial derivative of z with respect to x is equal to negative of fx divided by fz. Okay, so the implicit function theorem basically says, when you have an equation like this, if you have a point where fz is not 0, right? So if this fz isn't 0 at a given point, then you can think of z as a function of x and y near that point. And the derivative of z with respect to x and y will be given by this formula. So the partial derivative of z with respect to y would be negative fy with respect to fz. Okay, so now, well, we just have to calculate what fx and fz is. And so if you look at this equation, if you look at capital F, right, what is fx? Well, fx would be, now you see, you are thinking of capital F as a function of x, y, and z, right? So now you're treating x, y, z as independent variables here. So when you are taking the partial derivative of f with respect to x, so y and z are fixed constants. So when you take the derivative with respect to x, you get what? So here you're going to get you're going to get 3, so negative and 3x squared, and the derivative of the second and third term would be 0, and the partial derivative of 6yz with respect to x would be 6yz, right? Plus 6yz. Okay, what's the partial with respect to z here? So the partial derivative with respect to z here would be 0, 0. Here I get 3z squared, and here I'm going to get 6xy. So the partial with respect to z would be 3z squared 6xy. So 3z squared plus 6xy. Okay, so that's what I get for that. Let me put a line here. Okay, so what am I getting here? So here I have to find the partial of f with respect to y. So with respect to y, we're gonna get 3y squared plus 6xz plus 6xz, and with respect to so let me put the negative here. With respect to z again, we're going to get 3z squared plus 6xy. Okay, so now if you look at what I got before, right? So before, this is what I got. And if you compare that with this, right, they are the same thing, right? Except that I wrote the negative in front of the fraction here. Here I distributed the negative right here, right? So I got the same answers in both cases. So if you use, you can use this formula if you want,